or inequalities before, right? So and or. And when we solved and inequalities, they were written something like this. X is greater than -3, but less than 5, okay? X is greater than -3, but less than 5. Notice I know it looks like a greater than symbol, but because I read it from the X. So then you know you have your -3 here, your 5 here, and it's kind of a little weird because be very careful. The numbers that are existing in the problem are not where they are in relation to each other on a number line, right? So we got to be careful that we don't just place them on the number line like that. So it's greater than, let's put a little line under here. It's greater than -3, but you have to stop at +5, and that is what your typical and looked like, right? Sometimes it had the arrows that were going this direction. So in an and, most times they work out to be crossing each other. If you had an or, that kind of looked like this. The first thing, it wasn't written combined. Or statements cannot be written combined. It would say, hey, give me a number less than or equal to 5, okay? Or give me a number greater than 11. And that graph looked kind of like, instead of the two arrows in inequalities going the same way, they went opposite directions of each other. These numbers are all greater than 11. These numbers are all less than or equal to 5. So give me a number that fits one of these two. The answer would be anything greater than 11 or less than or equal to 5. We did talk about kind of another slick way to write your answer, because does anybody remember how you could say some or answers instead of saying the numbers they could be, Denisa?
All numbers except.
Yes, you could say all numbers except. And if it's like a simple little set of numbers, like in this case, what are the only numbers that it can't be if this is 5 and this is 11? It can't be 6, 7, 8, 9, 10, or 11. So you could, if you wanted to, list all those numbers out. You could say it could be all numbers 6 through 11, actually. Okay? So now today we're going to talk about when weird things happen. That's your standard and an or. So we've seen the two arrows going the same direction. We've seen the two arrows going the opposite direction. Crossing over each other. What we haven't seen is when they both go like that. Okay? So let's talk about this. Let's say I started, and I'm just jumping right to the graph because I know that you know that this inequality, let's color this in, is X is greater than or equal to 5, and this one is X is greater than 8. Okay, and notice I didn't put a word in here yet because we're going to talk about what the solution would be if this were an and what the solution would be if this were an or, okay? So if I put, and I'm going to put it in pencil because I'm going to erase it in a minute. If I said, hey, what would the solution set be if this were an and? Give me a number that is greater than or equal to 5. Oh, and by the way, it has to be greater than 8 too. What's the first number that would qualify for both? 9, right? Because it's an and, what did we say to look for an and on a graph? Overlap. So is there overlap at 8? No. If 8 was colored in, would there be overlap at 8? Yes. So basically, my overlap doesn't start until X is greater than, I could either say X is greater, I would actually say X is greater than 8. So this one would be my actual answer. I'm going to say that again for those of you who just kind of walked in. Listen up. We see a weird looking graph. They normally go either this way or this way, but when they both go the same direction, and if I say and, you can't say 6 because, yeah, it's greater than or equal to 5, but it's not also greater than 8. Does this make sense to you? This is actually a really weird concept in algebra because it's not like methodical and like solve this step. It's just kind of common sense, isn't it? So if you have to think of a number that fits both of those, then always pick the one that is closest to where the overlap starts. So as long as you give me a number greater than 8, why don't I want to say this? greater than or equal to 9? Yeah, because you know what then? You're discounting and forgetting about all those numbers in between 8 and 9 that also fit this, okay? Does everybody understand? All right, I'm going to erase this. Let's talk about if this were an or. Do you think that would change my solution? It sure would, okay? Listen to this. Hey guys, come up with a number that's greater than or equal to 5. Or if you don't want to do that, just come up with one greater than 8. This time, which solution would work? Do I need overlap in an or? No. So could I then maybe consider 7 or 6 or even 5? So in this case, would this one be the answer if it were an or? Are you seeing this? It's really just asking you to think about it. Okay, so in an and, I need overlap. Okay, in an or, I just need there to be one line above that. So there doesn't need to be an overlap. So the one line starts here. So let me just make sure you understand. If I gave you this problem with the word and in the middle, your answer would be this, anything greater than 8. If I gave you it with the word or in the middle, your answer would be the other inequality. Does that make sense? Okay, so let's talk about this. 10, negative 3. So this is obviously the inequalities. X is less than negative 3. X is less than 10. If I put the word and in here, you immediately say, let me say it. Hey guys, come up with a number that is less than 10. Oh, and by the way, the number also has to be less than negative 3. You can't say 9, 8, 7, 6, 5 because there's only one line. But what can you start at? Which one of these could you start at? Where the overlap starts. So if this had a word and, then that would be my answer. Any number less than 2 fits both, Mrs. Z. The minute I change that and to an or, then you could bump it back and your solution could be any less than 10. Are you with me? So if this were an and, then they both have to be true. If it were an or, then it only has to be true for one of them. So I'm going to include all those numbers that I couldn't include in an and. Okay? Here's the other thing that happens. And I said, normally ands look like this. What if an and looked like that? Meaning, ready? Just kind of blow your mind a minute here. Hey, I want you to come up with a number that is less than 5 and greater than 8. Okay? You're going to graph every single one of these just because it's going to help you. Here are the numbers less than 5. Here are all the numbers greater than 8. Do you see any overlap anywhere? No. So is there a number that fits both of these? No. So guess what we call this? We call this an empty set. A 0 with a symbol, like a little slash through it, means empty set. So if I were to say all the numbers, it's kind of like saying, hey, my solution is a set of numbers, and in that set of numbers, there are no numbers. So what could X be? Nothing. That's an empty set if it were an and, right? So now let's do the opposite. What if, instead of my or looking like this, what if my or looked like this? What would that mean? If I were to say, hey guys, give me a number less than 12 or greater than 6. It's the first thing I would do every time because the shape of your graph is going to help you answer it. So these are all the numbers greater than 6. And these are all the numbers less than 12. Hey, give me a number where there's at least one, where it fits at least one. Guess what your answer would be? The opposite of empty set. Wouldn't every single number you could think of fit at least one of those two? So this would be If your or looks like this, every single number on the number line is covered. So you could say all numbers. And that's just a quick little, kind of like the special cases. For the most part, I think we're going to stick to your traditional ands looking this way, your ors looking this way. Let me ask you, no, we already did this one, so we're good. Does everybody understand that? Okay, so those are special cases.